Let us now learn how to write numbers in scientific notation. Some numbers, especially the big numbers, are best represented using scientific notation. For example, if I write 2 million, for example, that one can be written as 2.0 times 10 to the power 6. So what you're saying is that we have 6 zeros after the 2. That's what 10 to the power 6 means. Okay, now also 0.200000, 0.200000 can be written as 2 times 10 to the power negative 1. That means there is 1 0 before the 2, and that 0 is followed by a decimal point. Alternatively, 0.0002 can be written as 2.0 times 10 to the power minus 4. That means there's 4 zeros before the 2 and a decimal point after the first 0. So this is what by introduction we are going to do. So follow me closely. So the scientific notation is usually written in the form of y times 10 to the power x. The x is the exponent, that is any positive or negative. You see this is positive 6. Okay, any positive or negative 1, negative, any positive or negative whole number will be the x blue exponent. The y, this red one, is called the coefficient. It's a number between 1 and 0 usually. Let's see how to do this. The learning objective here is to know how to convert a standard number to a scientific notation. So standard number is one that lacks 10 to the power x, you know. So example number 1, convert these numbers, these standard numbers, to scientific notation. This is 2500. Pretend that there's a decimal here. So we are going to the left 1 step, 2, and 3. We want to be left with 1 digit here. So it's 2.500 times 10. When you're going to the left, it's going to be positive. And we went 3 steps. 1, 2, 3. So positive 3. Okay. Now, if you are asked to report this to two significant figures, it's just going to be 2.5 times 10 to the power 3. Let's look at this. The decimal point is here. It's shown. We are going to the right 2 decimal places to where we have a digit between 1 and 10, which is 3. So it's going to be 3. It's going to be 3.6 times 10 to the power. Since we went to the right, how many steps? 2 steps. It will be negative. When you go to the right, it's going to be negative. Moving the decimal point to the right, use negative 2. Okay. This number is ambiguous. There's no decimal place, but assume there's a decimal place here. You're going 1, 2, 3. You have to have a digit there at the beginning. Any number between 1 to 9. So this can be written as 2.5 times 10. Since we went to the left, how many steps? 3 steps. So it will be plus 3. So when you're moving to the left 3 steps, the number will be positive. When you're moving to the right, in this case, we move 2 steps, the number will be negative 2. That's the scientific notation. Okay. So to convert a number in scientific notation to standard number, you use the reverse procedure. So for example, 2.800 times 10 to the power 2, this 2 means that you're going to move your decimal point 2 places to the right. So it's the opposite procedure, because now we are going from scientific. So if you're going to the right, if you have a positive exponent, you are moving your decimal point to the right by the value of the exponent. So in this case, we are moving it 2 places to the right. So from here, 1, 2. So our answer here will be 280.0, which is what's shown here. Remember, when you're going from standard to scientific, when we are moving to the right, the decimal point to the right, from the standard to scientific, the exponent was negative. Okay, so now here we are moving from scientific to standard. We are moving to our right, to the right, because our exponent is positive. Okay, that's why we are saying to convert a number in scientific notation to a standard number, the reverse procedure applies. Reverse of what we did, converting standard to scientific. Now it's scientific to standard. Okay, so when the power is, this is the scientific notation given. So when the power is negative like this, that means that we need to move. Okay, here we need to move the decimal point to the left 2 places. So decimal point is here, so we go 1, 2. It lands here. Okay, so there's gonna be a 0 here, and then we put our period, and the answer will be 0.0280. This will be the standard form of what? Of this scientific notation. Let us do some examples. Here is a worksheet on scientific notation. Question: convert the following standard numbers into scientific notation. This is 3,400. So if I'm to work on the first one, 3,400, I'll assume the period is there, decimal is there, and usually we want to be left with a number between 1 and 10. So that would include 1 to 9. So we'll want to move this to the left once, twice, thrice. So I'm left with 3 here, which is between 1 and 9, or between 1 and 10, I should say. So then scientific notation will be 3.4. Someone can write 00 times 10 to, since you are going from standard to scientific notation, if you're going left, the exponent has to be positive, and it's positive 3. This is 4 significant figures. If you're doing a problem and probably it wanted 2 significant figures, you will write it as 3.4 times 10 to the power 3. Okay, so this is 3.4 times 10 to the power 3, and we are on number 2. Number 2, we are given 0.000023. Notice the decimal place is here, decimal point is here, the period is here, so we are moving to the right. 1, 2, 3, 4, 5. We stop here where at least we have one number between 1 and 10. So it will be 2.3 times 10. Since we went to the right and we went 1, 2, 3, 4, 5 steps, we put -5. Okay. Now we can do question number 3. We are given 101,000, which is 101,000. Convert it to scientific notation. Assume the period is here, the decimal is here, so we're going to the left. 1, 2, 3, 4, 5. That's where we stop, where we have at least a number between 1 and 10, in this case 1. So it's 1.01, and you can list the rest of the digits times 10. Since we went 1, 2, 3, 4, 5 steps, it will be +5 because we went to the left. When you're doing standard to scientific, going to the left, the exponent will be positive. It's the opposite for whenever you are doing scientific to standard. Going to the left, the exponent will be negative. Number 4, we have 0.010. What is the scientific notation of this? Okay, so the decimal point is here, so I'm going 2 steps. 2 steps to the right. That means my power is going to be negative. Going to the scientific notation, so 1.0 times 10 to the power times 10 to the power negative 2. By the way, the top one here can be written as 1.01 times 10 to the power 5 if you are reporting it to 3 significant figures, you know. So that's how you do that. Next question, convert the following numbers to standard notation. Notice that we are given the scientific form of it. We are given the scientific notation, and we are going to the standard form of it. Now the first one that we are given right here is 2.30 times 10 to the power positive 4. Okay, let me write it again. 2.0 times 10 to the power positive 4. That will mean that I have to go to the right. The positive is telling me in scientific notation, when it's positive, I have to go to the right 4 places. 1, 2, 3, 4. And I'm going to include zeros there. So when that happens, the decimal ends up here. That number is going to be 23000. 23,000. So the answer here is 23,000. You can put a period there or not put it, but that's correct. Okay, number 2, we have 1.76 times 10 to the power minus 3. This negative here is telling me from scientific notation I need to move the decimal to the left. Move the decimal to the left. 3 steps. So let me write the number again here, and then we're going to move it once, twice, 3 times. The decimal will end up here. I include 0 here in this vacuum. The number here, when written well, is 0.00176. So the answer here is 0.00176. Now we do the next number 3. The next question, 1.901 times 10 to the power minus 7. This one, the negative on the scientific notation tells me that I need to move the decimal point 7 steps to the left. That's what it's telling me. So I'll write the number here for lack of space, and I need to move it 7 times backward. 1, 2, 3, 4, 5, 6, 7. So decimal point ends here. Where I have these bumps, I'll put zeros. So this number answer is 0.123 4, 5, 6. 1, 2, 3, 4, 5, 6. 1901. So that will be the number here, 0.12345 1901. Okay, so that's how you convert scientific notations to standard, and here that's how you convert the standard to scientific. So this value here, the scientific is 2.3 times 10 to the power minus 5. This one we decided it was 1.01 times 10 to the power 5, and this one was 1.0 times 10 to the power minus 2. Practice, practice, practice.